All right, so we're going to go ahead and go over activity 123 electrical circuits, the simulation, problems number 33 through 35. So what they want you to do is they want you to set up a circuit on Tinkercad that has a total of 3 light bulbs, and they are going to be essentially hooked up in parallel with 2 of the bulbs hooked in series with each other. So electrical current flows from the power supply through this bulb and back to ground, and from the power supply to this pathway through this bulb, and then through the second bulb, then back to ground. So this pathway and this pathway are parallel to each other, but these 2 bulbs are in series with one another. If I were to take out this bulb here, this bulb would turn off. But it would have no effect on this bulb, as the pathway from positive to negative would not be broken. So what they want us to do is to measure the total current in the circuit, which I can actually see from my power supply here. This shows a current of 156 milliamps being drawn by this entire circuit. So on Tinkercad, this power supply is really nice. It gives you the precision that you want. On your typical power supplies, you typically do not have the advantage of having that precision. So you usually have to use a multimeter to measure that. So what we're interested in knowing is, what is that total current through this entire circuit? We can use a multimeter to determine that. What is the current through just this one pathway? What is the voltage drop across this one component? What is the current through this pathway? What's the voltage drop across each of these components? And so what we do is we, on Tinkercad, set up this circuit here to where we take multimeters and we set them up to measure exactly those things. So what I do is I'm going to go ahead and disconnect these 2 wires here, and I want to go from the positive through a multimeter and then to these 2 branches here, these 2 pathways. And so I have a multimeter set up. So from the positive, I'm going to go through the multimeter and then out into each of these. So all the current flowing in my circuit is going to travel through this multimeter before it gets into these 2 pathways. So this is giving me a reading of the total current in my circuit, and you can see that it matches what's on my power supply. Then to measure the voltage drops across each of these bulbs, I brought in a multimeter and just hooked them up in parallel, straight to positive and negative on either side of the bulb. And you can see that it's set to the voltage setting. And so I'm getting a voltage drop reading across each of these. Now, Kirchhoff's voltage law for a series circuit, so if I look at this series pathway, I can see that the 2.5 plus the 2.5 does in fact add up to 5 volts. And in a parallel circuit, since each pathway is connected directly to the power source, there should be 5 volts across this pathway and 5 volts across this pathway. And I can see that I have 5 volts across this first pathway and 5 volts when I add these 2 up across the second pathway. So these 2 multimeters here are measuring the current in each of those individual pathways. So before I get to the negative or the ground on my power supply, I'm going to allow the current to travel through this multimeter, back out, and then to ground. And then same thing here, I went ahead and put it in between the 2 bulbs. And so before the current can flow from this bulb to this bulb, it has to travel through the multimeter, back out, and then into this bulb here. So this is giving me a current reading through this pathway, and this one's giving me a current through this pathway. So what they want us to do is to determine the entire resistance in the circuit a couple different ways. So I know that total resistance is equal to, if I go back to my Ohm's law, voltage equals I times R, I can rearrange and solve for the resistance, which is equal to V over I. And so if I know that the voltage supplied to my circuit is 5 volts and my current is 156 milliamps, which would be 0.156 amps, I can use this to determine that total resistance in the circuit. And I end up with a total resistance of about 32 ohms. Now, they want us to solve it a couple different ways. So it says calculate the total resistance using both Ohm's law and the following relationships. And so they give us the total resistance for a series circuit, and they give us the general equation that we see in the formula sheet. And then they give us the total resistance equation for a parallel circuit, and they give us the general equation that you see in the formula sheet as well. And the denominator should actually continue on depending on the number of pathways you have. Okay? So what I really need to determine are what are the individual resistances of these bulbs. Now, if I take a look at this first pathway, I can see that I've got a voltage of 5 volts at that bulb and a current passing through this pathway of 104 milliamps. So using that piece or that information, I can go ahead and determine what the resistance in that pathway is by taking voltage and dividing by current. So 5 volts divided by 0.104 amps, and that's going to give me a resistance of that bulb of about 48 ohms. Now, since all three of these bulbs are the same, I should have a 48 ohm bulb here, I should have a 48 ohm resistance bulb here, and I should have a 48 ohm resistance bulb here. I can verify that by recognizing that I have at this bulb here a voltage of 2.5 volts and a current passing through this pathway of 52.1 milliamps as seen from this multimeter here. So using that information, I can see that R is equal to V over I, so 2.5 volts divided by 0.0521 amps, and I end up with a resistance of about 48 ohms as well. So I can verify that that is 48 ohms. So going back to my original circuit schematic, I know I have 48 ohms here, I know I have 48 ohms here, and I know I have 48 ohms here. Since these two bulbs are in series with one another, I can get a resistance in this pathway of 48 ohms plus 48 ohms. I'm going to add those two resistors up, and I get a resistance in that pathway of 96 ohms. So I have 96 ohms of resistance in this pathway, 48 ohms of resistance in this pathway, and now I can use my total resistance of a parallel circuit to determine the total resistance in my entire circuit. And that's going to give me 32 ohms of resistance, which is what we determined earlier using Ohm's law with the voltage supplied to the circuit and the total current. So we solve for a total resistance a couple different ways. That's what they're expecting for number 35 on activity 1, 2, 3 electrical circuits simulation. Thank you.